All right, there's a couple other theories I wanted to talk to you about with the properties of exponents. And they're kind of the trickier ones. They're not like the other three that we kind of explained together. So let's go ahead and talk about those couple other properties. So let's say I had this, for example. Let's say I had x to the negative second power as my answer, okay? And in mathematics, okay, negative exponents means that my number, whatever it's going to be, is going to be really, really small, okay? But whenever we're trying to simplify exponents with other exponents, we always want them to be positive if possible. Especially we want our final answer to have positive exponents always, because it makes it a lot simpler for us. So what we're going to do is, we're just going to practice the property where we get rid of negative exponents. Okay? So I'm going to put an invisible 1 there, okay, because below every number there's an invisible 1. And the way we get rid of negative exponents is by moving that term to the opposite end of the problem. So if the negative exponent term is in the numerator, we move it down to the denominator. And vice versa. If it was in the denominator, we move it to the numerator. So this becomes this. So if we move that term down to the bottom, there's nothing left on top. Or actually there is. There's an invisible 1, of course. And then on the bottom, I still have that 1 times. And then that negative 2 becomes positive 2. So I have 1 over 1 times x squared. But 1 times x squared really doesn't change anything. So we can just write 1 over x squared. Now the mistake that a lot of people will make is, oh, wait a second, I already know that. I could just flip the fraction, right? I just flip over 1 and x to the negative second, and I get my answer. But I'll show you an example where it's not quite that easy. Okay? Here's another example that we can see. Let me just go ahead and do 1 over y to the negative 4th power. Okay? So, again, my final answer should not have negative exponents. So I'm going to move this term to the top. Okay, so I saw the 1 on top, 1 times y to the positive 4th power, and on the bottom I have nothing, or I still have the invisible 1, which I don't have to write. But ultimately 1 times y to the 4th is y to the 4th, and I don't have to write the 1 on the bottom, so that's my answer, y to the 4th. Okay, so the crucial part here is that we want to get rid of negative exponents, and the way we do that is by moving the term with the negative exponents from the numerator to the denominator, or vice versa, from the denominator to the numerator. So let me show you one more example. So if I had something like this, so 3x to the negative second y cubed over z to the negative 5th power. Okay, so in this example, you'll notice I have negative exponents everywhere, but not everything needs to move. You'll notice that x to the negative second power has a negative exponent, but y has a positive 3. So that doesn't need to move. That term can stay exactly where it is. But the z to the negative 5th, that has a negative exponent, that needs to move. So this is going to move down here, and this is going to move up here. Okay? So I only need to move the terms with negative exponents. So the 3 doesn't change. The x negative 2 goes down to the bottom. I still have y to the 3rd on top. And the z to the negative 5th power now becomes z to the positive 5th power. So I move that term to the top. And now the x to the negative 2 needs to come down to the bottom, so it's x now to the positive 2 power. So I only need to move the pieces that have the negative exponents. Again, notice how y to the 3, y to the 3rd, that was great. Those are both positive. So we left it alone. But the other two terms needed to move down, either move up or down. So that is how you deal with negative exponents.